We're given a function f of x equals 1/2 x to the fourth minus 2x cubed plus 3/2 x squared, and we're asked to determine the maximum number of turning points of the graph. We're asked to find the real zeros for the graph. So we know that our function is degree 4. So the maximum number of turning points that this function could possibly have is 1 less than the degree, so it's equal to 3. To find the zeros, we're going to take our equation, 1/2 x to the fourth minus 2x cubed plus 3/2 x squared, and set it equal to 0. When you set a function equal to 0, a good rule of thumb to first try to do is factor out any terms that, or any factors that each term has in common. And so if we look at this, we can see that each term has a 1/2 x squared as a factor. So if we divide out 1/2 x squared from 1/2 x to the fourth, we'll be left with x squared minus, if we factor out 1/2 x squared from 2x cubed, we'll be left with 4x. The reason that we get a 4 is when you take 2 and you divide it by 1/2, that's 2 times 2 over 1, which is 4. And then when we factor out 1/2 x squared from 3/2 x squared, we'll be left with 3. So now we have the factor of 1/2 x squared, and we can now factor the trinomial x squared minus 4x plus 3. This factors into x minus 3 times x minus 1. So using our zero product property, if factors multiplied together equal 0, one of them has to be 0. So 1/2 x squared has to equal 0, which would give you x is 0. X minus 3 has to equal 0, which means x is 3. Or x minus 1 equals 0, which gives you x is 1. So the three zeros for this function are 0, 3, and 1.